Okay, so what we're going to be looking at is how we put data into a scatter plot. Now I've written this table out. It's in your book, so you don't really turn. If you open the book, it's a lot easier. Yeah, there you go. Right. No, your book. Page 157. Okay, so we've got this data. Now, I heard you talking and asking questions, and it means you didn't quite understand what's going on. So, this data, it's maybe slightly different to what you've seen before because it's not all in order. Okay, basically it's about, what is it about? A survey is carried out to compare pupils' ages with the amount of money that they spend each week. So here's what it is. It doesn't mean every 11-year-old spends £3. That's not what that means. What that means is there was one person, okay, who was 11 and they did spend £3. This one was a 16-year-old, spent £3.50. This one, 14-year-old, spent £6, and so on. So we've got, so I could ask you, how many people were surveyed? Sophie? 10 people. Okay, so we have 10 people here. Alright, so each one, that's one person, 2 people, 3, 4, 5, 6, 7, 8, 9 and 10. Each record is one person. Alright, that's important for it. It's not been put in any order because there's no point putting the ages in order because then the amounts won't be in order. It doesn't matter. By putting it in a scatter plot, that's when we start putting things in order. So we've got to draw a scatter plot to show this information. Now it gives you some information in the question about what to do, but let's talk about it as if we just have the data on its own. So do you remember we were talking about dependent and independent variables where one makes the other one change, we think. Now, without looking at the data, what kind of statement would you say about a relationship between age and money that is spent? What do you reckon, Jim?
The older the people are, the more money is.
Yeah, the older the people are, you would expect the more they would spend. So you'd think it could be a positive correlation. So before doing anything, we think that's what we've made a hypothesis. Okay. So, would it make sense to say the more someone spends, the older they are?
No.
Because that would make you, I want to be 18 today. I'm going to spend a few extra pounds on sweets.
No.
Doesn't make sense. Yeah. So we just say, as I get older, okay, I can spend more. Right?
Money doesn't affect you.
No, the money doesn't affect the age. The age potentially affects the amount of money. So we would say that the age is the independent one, independent variable, and the amount spent is the dependent one. So that means that this will be the y-axis, this will be the x-axis. Now, so we need to set out our axis, and we need to decide, when we have an axis, we need to decide what's the smallest amount and what's the largest amount. So for the x-axis, if we try and decide what it needs to go between, so x has to go from what to what? So the smallest number is, Sophie?
From 11 to 15. 16.
Okay, well we've got a 10 here. So we've got a 10 up to 18. So we might say 10 to 18. Okay. Now we might choose to go an extra one either side. Now the y-axis then would need to go from what to what?
250 to...
So 3, nothing lower, to 12. Okay. So 3. Okay. Well, let's just check. What does it say in the book?
The lowest one is 250.
250, yeah, okay. Yeah, we got that wrong, so it's not 3, it's 250. It's always worth checking. What does it say in the book? What should we do? It says use the x-axis from 10 to 20. Does that make sense? Yeah, 10 to 20, they've given an extra one. And what do they say for the y-axis?
Use the y-axis for amounts.
So they've gone from 0 to £15. Make sense? Okay, now here's the thing. The scale as well. We've got to make sure on the y-axis that it has to go up so that we can mark £half. But the years is all just 11, 12 and so on.
2 squares.
Okay, yeah, so we've got to consider that. So when I draw my graph then, I'm going to do y first because I'm going to put it right to this end and I'm going to start it, what did they say, 15, yeah? So I'm going to go, and it's got to go in halves, so I'm going to go 15, 14, 13, 12, it's going to be really big, isn't it? So you've got little squares in your book, so maybe I need to have little squares. So what I'm going to do, let's have a different piece of graph paper. Let's choose to have bigger little squares like this, so it's more like your book. So 15, so I'm going to go 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, so got my y-axis sorted out. And what about my x-axis? What did that have to be?
From 250 to 12.
So I'm going to go from...
3.
No, sorry, my x-axis, wasn't it? So
10 to 8.
So 10 to 18. So I just need to go up in one. So I'm going to go 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I'm going to go up to 20. And we draw my... And then by doing it that way, I make sure everything fits in on a page. Do you want to do yours now? You draw your set of axes now, using your pencil ruler, the same way I've just done mine.
So you went down to...
So I started, I think, 15, I'm going to 14, 13.
So you missed on your
Do you remember how I did it though? Start at the high numbers and go down, rather than start at 0 and go up. And put your numbers in afterwards. Yeah.
Do you have to copy it? No, that's a long one. And then the bottom one goes from double 20.
Right, make sure, guys, always very important when you put in a chart, when we're doing an axis, okay, you must label your chart. So on the sides, okay, you can write it, turn your book and write it up the side. I'm not going to try, but it's obviously amount spent in pounds in this case, okay, and then on the x-axis it's the age in years. It's very important we do that, okay.
So age in years.
Yeah, age in years, amount spent in pounds. So we think that the amount spent is dependent on the age in years rather than the other way around. So I can say this one is the dependent variable, that's why it's on the y-axis. Okay, dependent on the y-axis.
So the dependent always goes on the y.
Sometimes you might say that there isn't a dependent one. For instance, if we were doing a graph on someone's English score and their maths score, now you wouldn't say that their English score depends on what they get in maths.
Yeah.
You've also got to use your common sense.
Maybe it does. Because for example, you get a bad
In
grade.
this one you don't have to.
You get a bad grade, you have to get...
You get a what?
A bad grade. You have to get something really good to pass the... whatever it
Yeah,
is.
maybe, but then again, if your English came first, yeah, but what if your maths test was done first?
Oh,
Then
then
go
you
around.
failed.
Same.
Yeah, but what I mean is it's not really. I mean, we would say English and maths test score really depends on how much you study. So that'd be
Again,
a
that's why
better
you also
one.
have to use your common sense, because you don't have to know
And
that
Mr.
dependent goes
Potts.
on y. You can say that you can't put the amount spent on the bottom for the years.
Well, you can. The thing is, you can change these around.
It wouldn't make sense.
Well, it would be fine. You would still get the same graph, really. You would still make the same conclusions. It's just, again, it's technically wrong. That's all. It's so if you get them the wrong way round, it's not a massive disaster at all. It's not like, oh my God, that's completely wrong. It's just, it's like a spelling mistake if you're writing a story in English. What's more important, the spellings or the story? The story is more important. Should you get the spellings correct? Yes, you should. Okay? But if you don't get all your spellings correct, you can still read the story and enjoy it and get, without having everything spelled correctly. And it's the same thing. If I get those the wrong way round, technically, it's not great, but we will still make the same conclusions. We will still get the same correlation.
So would a mark be taken off if you got it wrong around in an exam?
Yes.
But as you said, it will still get to the same conclusion.
Yeah.
So why would it be
So
wrong?
it's technically right.
Because in an English
It's the way they
essay, a story, you'd still get marked down.
English essays.
No, it's the same thing. If it was an English essay, your story gets marked, but there will still be some marks for your spelling. Same way, the conclusions that you make, they're the most important, but there'll be a mark or two for what the graph looks like, and did you do it the right way round, and did you do the axis correctly, and all of that
Like
kind of
in science, you get a mark for if you draw to pencil and ruler, and then
Really?
use pen on the labeling and
Yeah.
numbers.
No, really, here.
So
Everywhere.
when you do a graph, for instance in maths, it's very important that you label the axes, otherwise you do lose a mark. Right, anyway, have we all got that drawn?
Yeah,
Yeah. Okay. One question? Yeah. What's up, Sophie?
Right. So the independent variable would be the variable that gets depended on? I don't know what.
Yeah, the independent one is the one that you think does the changing. So as my age if I get older, that causes me to have more money to spend. Yeah.
Why? Is it
So
pension?
get a job.
Pension?
Talk about your age, teenagers.
Pension.
As you get older as teenagers, you get more money because you might offer to do the washing up more.
I'm not a teenager.
No, I actually.
But look, these guys are 10 years old, 11 years old, 8 up to, that's their age group. And it's the same actually, as you get older, you tend to get more money in your job with more experience and you get better at it. I could extend this up to 50, 60, 70 years old. But again, do you remember we talked about limitations?
Yeah.
Yeah, you do, because you were asking about it. Remember, the limitations are, once I've reached the age of retirement,
You get free money.
we get less money though. You might
Once
get,
you get
get free
100%
money.
on a test, you can't revise more because
Exactly. So there will be a point at which this changes.
So if you have a factory, whatever you call it,
Yeah.
business. So business, you still win money.
in future, everyone.
Yes, but that's,
every person
again, a
living
different
should
situation.
Will you win the pension too? Only.
Only if you've put money into a pension. But if you have your own business, you might not have bothered. Right. Okay. Let's get into how we plot the points then. So each person has its own mark. So what we do is we go through now, using the table. Now I've got mine up here, but you've got yours in the book. This person is 11-year-old and spent £3. So on my chart, I've got to go to 11 years old, spent £3, and I'm going to put a little mark, a little cross. Not a big cross, a little one. And can we use pencil, just in case you make a mistake? Always use pencil for a chart, just in case you make a mistake.
Is it like around an 11-year-old spent £3 and went to
You left the
shop and
10-year-old
got a
in
spider
suppose.
in town?
Right?
10-year-old.
No, I haven't missed it. I've done that one. I'm going to go one at a time. The 16-year-old spent £2.50.
Three.
£3.50.
£3.50, you're right. The 16-year-old spent £3.50, so I put a mark there. You're going to go through and plot all your points.
Yes.
So we have our points plotted. You manage that?
Yep.
Okay.
Yeah.
Now, one thing to notice about a scatter plot and about the data, you'll notice, for instance, there are 2 crosses above the 13, which means there were 2 people at 13 years old, but they got different amounts of money.
Which is unfair.
Okay, there is also 2 people at 14. So you can have 2 people of the same age on the same scatter plot, so that's fine. Okay. Now, I think you've already decided, is there a correlation?
Yes.
What do you think?
Positive weak.
So
weak positive.
we would go for weak. You think weak positive. Now I'm going to definitely agree with the positive. The weak correlation is open for discussion. Now I'm going to give you another little
So if
bit
it's
of
a positive
vocab here.
correlation, it goes from left to right. Half.
Yes, it goes up. Yeah. This point here is potentially what we call
The downfall. No correlation.
an outlier.
Like, can you just put weak on any one and it would?
Well, no,
if you
because
don't definitely
see,
know-
I think you're right with weak. However,
like if it's a positive,
this is an outlier, and an outlier is
Don't you spell liar with A?
not liar as in like, Nico, have you done your homework? Yes, I
No,
did,
I
but I've left it
haven't.
at home. Not that
Yes,
kind of
yeah.
liar. Outlier as in it's not near the rest of the data.
Well, neither is the one at the very top.
Well, no, that one follows the path. Now, I think
For example,
if we get rid of this one, if we ignore that one, this
it would be
weak.
a positive.
Well, it's
Strong.
always
Strong,
positive,
strong,
but it
strong.
might make it strong. Yeah. So
But if we definitely knew it was a strong one, if only put weak, then would it make anything
yeah,
wrong?
I think
But Mr. Potts,
yeah.
it actually it can vary. It can be positive. It can be a weak positive or strong positive because you could put your line at 10, but you could make it more higher, but you can also make it lower.
Well, no. But the thing is, our line of best fit will only go in one place. So if we were going to do a line of best fit, now what you're going to do is different from what I'm going to do. If we ignore this point, because we think it doesn't really fit the data. Now this guy, 16 years old, didn't spend much money. Maybe he is saving his money, so he didn't spend it. Okay, maybe he's not got it to spend it. We don't know, but he doesn't really fit the rest of the data. Now, here's the thing about statistics. This is what we're doing. In statistics, if something doesn't really fit and will change your conclusion, you can mark it and say, well, I know it's there, but I'm going to consider it an outlier, so it doesn't really fit everything else. So I'm going to ignore it. And you are allowed to do that. But of course it changes your conclusion. Because like we've just said, we could say weak because of that one, but if I get rid of it, I could change it to strong. Now, that's fine. Whether you're right or wrong, that's for you to argue, for you to discuss, isn't it, Millie? With us? Now, my line of best fit, I'm now going to ignore this one, and I'm going to put it through these points. Now, what you should do is get your ruler and lay your ruler so you think it's going straight through, kind of near enough the middle of the points. Same above and below. Now, remember, it doesn't actually have to go through any of the points exactly, but to have it the same above and below. So that would be maybe my idea. But have a look with your ruler,
Can we
move it
try
around.
and get it into the middle?
So see what you think. Now it might be that you think maybe it was more like that. Maybe that's a better one.
And do we mark it?
So that is up to you. Maybe it's even different. But
The graph is much different. I think another one.
yeah, well, the thing is, your graphs will look different depending on the scale, but the same conclusion is
Why are
made.
you starting on 2.5?
It does- right.
You don't have to start at 0.
Right, you don't start at any particular number. It's all about the data. It's not about the axis. You start a line of best fit wherever the data is. It doesn't. If I start here, how do I make it fit the data?
Yeah, that's what I was saying. That's why it can change.
No,
It's
it can't.
strong.
I can't start it there. Remember what we said the other day. The line does not determine if it's strong or
But you
weak.
could go for 0.
The points determine if it's strong or weak, not the line. The line is determined by the points. Okay? You understand? So that line has to be where the points are. The points are nothing, they don't move. Alright? So I've got my line of best fit. Now, here's the use of the line of best fit. Alright, you can use it to make a prediction. So if I said, predict how much money, so let's say a parent said, well, I've got a 17-year-old daughter, how much money should I give them to spend each week? Now you could go, I have some mathematical data on this. Go on then.
Well, can you just go that you look for the 17-year-old
Yeah.
at the bottom, and then you go up?
Yeah, and we go up to
The line.
and we use the line, and then we read across.
But that means mine isn't correct, because it doesn't exactly line.
Well, no, it doesn't mean you're correct. It doesn't mean it's not correct. That's just the way you've done it. Okay?
Then if it's a bit off one of the points, it would be point something.
Yeah,
So
that's all, yeah.
17.
But I
It
can't
would
do
be
But
that.
You can tell the parent it's between 9 and 11. You can even
Exactly. You could say give them anywhere between 9 and 11. Yeah, quite right. Because here's the other thing.
21.
If we can't say you have to give your 17-year-old, in my graph for instance, exactly £10, because that's not right, because none of these other points are on the line. If they were all exactly on the line, then you could say, oh, exactly £10. But we would say, like Nico says, I would probably say anywhere between like 9 and 11 or 10, 9.50, 10.50 is fine, isn't it? Okay? If someone, I would say probably is, but it's just an estimate, isn't it? So if I said, estimate how much a 17-year-old spends, okay? The estimate, because it's not going to be exact, remember that word, estimate, you would say about, in my graph, £10. Now your graph, because your line of best fit might be somewhere else,
£13.
well it shouldn't be much different to mine.
£13.
Well, your 13 is a long way away.
Because I did my line of best fit differently too.
Well, then your line of best fit might be quite wrong.
I did it from
it's the same.
I did it from where the 11 is at the bottom, halfway between 10 and 11, and I went up.
Here you go, now it works.
See, if you're saying you're
Well,
17-year-old,
I did from there and I went up there, halfway between the.
yeah, see, yeah.
It's fine, but
Oh
then
my god.
The trouble is, then you've got the 17-year-old getting the most money, and that doesn't make sense.
Why?
Well, because
20-year-old should have known that.
well, the 18-year-old.
Not necessarily.
Well, no, look, necessarily. You've got the 18-year-old and gets 12 or spends £12. Using our relationship, the 17-year-old should get less. If your line of best fit suggests that they get more, there's probably something wrong with your line of best fit.
But it
Okay.
doesn't work.
Doesn't have to be exactly
No,
10.
it goes to 10 and a half.
That's fine. It's £10.50 then. Sophie, don't get too hung up about it. It's just a prediction. It's roughly, yeah?
It doesn't matter. It's just because yours has probably got more squares in one place than yours.
Well, you should. My line of best fit, I did by eye as well. There's no gap. Why is mine isn't any more right than yours? Yours might actually be more right than mine. And when we can do one mathematically, then we've got an exact solution. And I'll show you that next. But what I want you to do is do question 2 yourself. And what I'll do is I'll show you the mathematical version. Right?